Today we'll study about minimum number of teeth on a gear to avoid interference, and this derivation will be continued for minimum number of teeth on pinion to avoid interference also. To get this equation, let us consider the critical addendum circle radius of gear. The limiting number of teeth on gear can also be calculated. So let us consider O1 as the center of the gear and O2 as the center of the pinion. So let us join this center of a gear and pinion. Let us draw the pitch circle of the pinion. So this is the pitch circle of the pinion, and this is the pitch circle of the gear. This is the addendum circle of the pinion, and this is the dedennum circle of the pinion, and here we have addendum circle of the gear, and this is the dedennum circle of the gear. The radius of the pitch circle of the pinion is given by symbol small r, and similarly radius of the pitch circle of the gear is given with capital R. And we know that the addendum circle radius of the gear, we can give it as RA. We can give it as RA as the addendum circle radius, and similarly we can give it for a pinion as small ra as the addendum circle radius. The distance between the addendum circle and the pitch circle is nothing but the addendum, and here we have the distance between the addendum circle and the pitch circle for gear as a addendum. So these are the basic parameters, and let us draw the tangent passing through the pitch point. Point M and N are called interference points. That is, if the contact takes place beyond M and N, interference will occur. So let us join this O to M and O1N. Now let us consider angle phi is pressure angle, capital R as the pitch circle radius of the gear, which can be written as module into number of teeth on the gear divided by 2. Small r is the pitch circle radius of pinion, so which can be written as module into number of teeth on the pinion divided by 2. That is, capital T is the number of teeth on the gear, small t is the number of teeth on the pinion, M is the module. AW is the addendum constant for the gear or wheel. AP is the addendum constant for the pinion. So when you multiply this addendum constant with the module, we'll get addendum of the gear, and when we multiply addendum constant of pinion with the module, we'll get the addendum of pinion, and we have gear ratio as a number of teeth on the gear to the number of teeth on the pinion. Now considering triangle O1MP and applying the cosine rule. Here we have triangle O1MP and applying the cosine rule. Cosine rule says that side C square is equal to side A square plus side B square minus 2AB into cos of angle C. Now applying the cosine rule for the triangle O1PM, we have O1M square is equal to O1P square plus PM square minus 2O1P into PM into cos O1PM. So that we are going to write now. That is O1M square is equal to O1P square plus PM square minus 2O1P into PM to cos of O1PM. From triangle O2PM, we have PM is equal to O2P divided by sin pi. That is, PM is the opposite side and O2P is the hypotenuse. So opposite divided by hypotenuse will get sin phi. So writing the equation for PM, we can write PM is equal to O2P into sin phi. And from angle cos O1PM, we have it as a cos 90 plus phi. So let us see the figure. This is O1PM. So here we have this angle as a 90 degree and this as a phi, because here opposite angle is the phi. So we can say this as angle, the whole angle as 90 plus phi. So here we have cos of 90 plus phi. So substituting PM as O2P sin phi and cos O1PM as cos of 90 plus phi in the above equation here. So O1M square is equal to O1P square and PM as O2P sin square phi. So here we have O2P square into sin square phi minus 2 O1P and PM as O2P sin phi and cos O1PM as cos 90 plus phi. And from the figure we can see that O1P is a pitch circle radius of the gear, which is given by r square, and O2P is the pitch circle radius of the pinion, which is given by small r. So it is r square, capital R square plus small r square into sin phi. For this I will come later, into 2. O1P is capital R, O2P is the small r, into sin phi, and here cos 90 plus phi is a minus sin phi. So minus minus will become plus, and sin phi into sin phi will become sin square phi. So here we have this equation. Now taking r square as a common outside, so when we take r square as a common outside, so here we left with 1 and here it is r square divided by r square sin square phi plus 2 into r divided by r, because this r and r square will get cancelled, we left with divided by r into sin square phi. Again simplifying this equation, r square outside 1 plus, and between these two equations we'll take r divided by r into sin square phi as a common. So when we take r divided by r into sin square phi as a common, here we left with r divided by r, so r divided by r plus, and here we left with only 2, so it is 2. So O1M square is equal to this. If I write this equation for O1M, then this square and this square will get cancelled and the term in the bracket can be written under the root or raised to 1 by 2. So next here we have O1M is equal to r into 1 plus r divided by r sin square phi, r divided by r plus 2 whole raised to 1 by 2. Now we'll replace this r with mt by 2. We know this earlier, so replacing r with mt by 2 plus, again small r, for small r we have module into number of teeth on the pinion, that is small mt divided by 2, and for capital R we have m into capital T by 2. Here m by 2 and m by 2 will get cancelled and we left with small t divided by capital T into sin square phi. Similarly here also we get small t by 2, small t divided by capital T, since m by 2 and m by 2 will get cancelled, plus 2 whole raised to 1 by 2. Therefore O1m is equal to mt by 2 1 plus the gear ratio, we know that gear ratio G is equal to capital T by small t, and here we have small t by capital T, so it can be written as 1 by G. So 1 by G sin square phi, again it is 1 by G plus 2 whole raised to 1 by 2. We also know that O1m is equal to, if you look into the figure, O1m is the addendum circle radius for the gear. So O1p is the pitch circle radius of the gear plus addendum of the gear. So total length will become addendum circle of the gear. So O1m is equal to O1p plus addendum of the gear. O1p is the pitch circle radius of the gear, so it is given by capital R, plus length of the addendum is given by addendum constant of the wheel into the module. So this capital R can be written as mt by 2 plus addendum constant into the module. So let us call this O1m above equation as equation number 1, and this O1m is as equation number 2. Now equating equation number 1 and 2, we have mt by 2 plus aw into m as it is equal to this term, this complete term, mt by 2 1 plus 1 by G sin square phi into 1 by G plus 2 whole raised to 1 by 2. So equating these two terms. So when we equate these two terms, we can cancel this module here, here and here. The module will be cancelled throughout the equation. Next we'll write this equation for constant AW. So when I write this equation for constant AW, this t by 2 I will bring it on this side, so it will become minus t by 2, and this whole term as it is. Here we have cancelled m, that you should remember, so it becomes t by 2, the whole term in the bracket as it is, and this t by 2 on this side, it will become minus t by 2. Next what we will do, we'll take this t by 2 as a common factor and we'll take it outside. So we'll take t by 2 as a outside, so we left with the term in the bracket as it is, that is 1 plus 1 by G sin square phi 1 by G plus 2 whole raised to 1 by 2 minus this t by 2 we have taken already outside, so it becomes 1, and we'll complete the bracket. Again, actually we need to find the number of teeth, minimum number of teeth required on the gear to avoid the interference. So number of teeth on the gear to avoid the interference, we'll write this equation for t. So when I write this equation for t is equal to 2 will go to the numerator, so it will become 2aw, and the term in the bracket as it is, so this is the equation for number of teeth required on the gear to avoid the interference. Next we'll see number of teeth required on the pin to avoid the interference. So number of teeth on the pinion to avoid the interference, small t is equal to capital T by G. So whatever we had written the equation for capital T, that is number of teeth required on the gear, so divided by gear ratio. If you do that, you will get the minimum number of teeth required on the pinion to avoid the interference. In case if the number of teeth on the gear is equal to number of teeth on the pinion, then the gear ratio will become 1. Then the equation can be rewritten as capital T is equal to small t is equal to 2AW divided by 1 plus 3 sin square phi raised to 1 by 2 minus 1. So this is all about minimum number of teeth required on the gear and pinion to avoid the interference. Thank you.